In a previous video, we've seen that we could generate the tan function using this Taylor series approximation. But we noted that the approximation is only accurate over a small domain. So whenever we head out past this point here, out in this direction, or if we head off in the negative direction, then we don't have any accuracy. But we do have a solution for this. Now we can use the simple trig identity that tan x is equal to sin x divided by cos x. And we know we've got a method of generating the sin x and cos x over the entire domain. So in order to work out, for example, the tan of 30 degrees, what we can do is we can work out the sine of 30 degrees. And then from the sine of 30 degrees, we can work out the cosine value for 30 degrees as well. And that's going to be the sine of the 90 minus the 30. So it's going to be sine of the 60. So once we've generated both of these, we can then divide them. And when we have divided them, we will have our final answer. So in the example we're going to look at, we're going to generate the tan of 30 degrees, which is 0.57735. So the correct answer we should get out whenever we run the algorithm is 0093. So let's see the code. So on the right we have the calling function, on the left we have the subroutine. So all we're going to do is take a value for our x in radians. In this instance here we were looking at 30 degrees, which is 0.523598 in radians. So we've got this value in here, and we're going to push that value into the subroutine. So I've called this subroutine tangent shift. So it jumps over to the subroutine on the left, it runs through and it generates the tangent function. So it's going to generate it by first generating the sine of the function and then the cosine of the function and then doing the division and then returning the result. So when it returns the result, it will return it into this tan shift memory location. So if everything works out okay, the final answer should be 0093. So let's look at the actual subroutine function here. So in the subroutine function, we have to do three things. We have to do the sin x, which is done here. We have to do the cosine shift, which is done here. And then we have to do the division, which is the sin x divided by the cosine shift. So I've got each of these here. So it's just a matter of taking the value that we have for the input, and then we can push it into the subroutine for the sine, and we pop the value, the answer out. And then we do the same, we push the value into the cosine shift and we pop the result out. And then we just simply go through the division algorithm. So we push the two values in, we go through the division algorithm, and then we pop out the answer. And then we store the answer in tangent shift, and we push that tangent shift onto the stack. Once it's on the stack, we then return to the subroutine and we are able to pop that answer back off into the memory location here, tangent shift underscore x. And that's the end of the code. So let's see it working. So I have loaded the subroutine into the ROM and the program into the RAM. So we're trying to work out the tangent of 30 degrees. So I will fast forward this and we'll have a look at the actual result. So the simulation has now finished. Let's drop in and we will see the final result. Now the result we're hoping to get is 0093, and you can see here we've actually got 0094, so we're only in effect 1 unit of resolution out. So this means that we're now able to generate the sine, the cosine and the tangent functions over their entire domain. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.